Today we are going to learn about the boundary layer equation. Myself, Avishkar Khemnar, I am going to present the video on boundary layer equations. My roll number is 2020. Let's start the video. In the fascinating world of a low-speed aerodynamics, one key concept play a crucial role: the boundary layers. Today we will going to in-depth of the topic and learn.
The boundary layer is a thin layer of air that develops along the surface of an object moving through a fluid, such as air. In the context of low-speed aerodynamics, we encounter the boundary layers in various sections, from the wings of the aircraft to the surface car and even the underground vessels. The boundary layer equation it derives from the principle of fluid mechanics and it describes the flow within the layers. Within the boundary layers, it is also allowed to calculate the parameters such as velocity profile, pressure distribution, and the skin friction drag. To understand the behavior of the boundary layer, we need to examine the boundary layer equation. This equation provides us the insight to the characteristics of the dynamic of the crucial layers of the air.
Now we can start the derive the equation. In the screen you can see where we mark the some parameters like
See there the velocity parameters are given there. So you can see there the parameter. So we can remember that we have the flow that is coming into the plate and a flow which is the velocity u infinity, and it is a hit a plate from the boundary layer. So a fluid is the some temperature which is T infinity, and the boundary layer this is delta, and the temperature it is Ts, and x is the length of the total plate. Y is the coordinate, it is a distance from the perpendicular of the plate. So the velocity of a boundary layer it is going to the function of x, and this is the distance along the depth upon the L. L is the total length of the plate, and the V is represent the U infinity. So the velocity of the fluid, rho is the some density of that fluid, and mu is the viscosity. So we have these 7 parameters totally. The x star would be represent the dimensionless variables, and it is going to define as the x is equals to x by L, the total length, and the y start it's going to y divided by L, and the dimensionless velocity u state that the mu by magnitude of v. Now the temperature we already defined the T star temperature dimension less temperature, and T of y minus T of s divided by T infinity minus Ts. Or we can also say that a T star is equals to T star of a y star of. So doing the some derivatives, we have the derivatives of the T star with respect to the total derivative of y star is equals to the partial derivative of T star with respect to y multiplied by dy divided by dy star, and this is equal to the derivative of T star with respect to y is the derivative of this term. So we have this is constant, so we the derivative is equals to the 1 divided by t infinity minus ts multiplied by dt
by dy. Now the y star is the derivative of the y. So the y star is equals to the L. So this is multiplied by L. So dt star divided by dy star multiplied by 1 divided by L is equals to T infinity minus Ts multiplied by dt by dy is negative, then one can swap these two terms, so it has a minus. So equation be like minus dt star divided by dy star multiplied by 1 divided by L is equals to 1 divided by T infinity minus Ts multiplied by W T minus dou y. By solving the above, we solve the by solving the derivatives, we get the these equations. Now from these equations we get the boundary layer equation.